Did you see those purple elephants marching down the street? Did you see them? Go look! Go look right now! Purple elephants marching down a street. They're very important for today's lesson. Our lesson today is about order of operations. So let's see what our agenda is for today. First, we're going to talk about our learning target. Then we're going to have our lesson. Then you'll have something to do in IXL. And don't forget to fill out the exit ticket at the end of the lesson. So today our learning target is I can evaluate expressions with multiple operations without grouping symbols. What does that mean? Well, like I said, we're going to talk about the order of operations. And I want you to look right here. The order of operations is a set of rules that tells the correct order to use to solve a problem that has more than one operation. Because an expression can only have one value, these guys over here studied math and they agreed on a process for everybody to follow so we all get the same answer. This process is called the order of operations. We have Archimedes, Isaac Newton, Pythagoras, and Euclid. They were all big names in math, and they made the rules that we're going to talk about today. There's those purple elephants marching down a street. You might have learned, please excuse my dear Aunt Sally. Look at her face. What did she do that she needs to be excused? Well, no matter which one you want to use, purple elephants marching down a street, or please excuse my dear Aunt Sally, that is a way for you to remember which order you are going to do your math. There are two ways to remember. So, the P starts with parentheses. You always solve what's in parentheses first. Then the E stands for exponents. You have to do the exponents next. Then, marching down, multiplication and division are the next operations you use, and you do them in the order that they are in the original problem. Same with addition and subtraction. That's my A street, right? Addition and subtraction are the last things you do, and you do those in the order in which they appear in the original problem. So, this is something that I would like for you to take a screenshot of. This explains exactly what the P means, what E, M, D, A, and S means. Okay, this is something that we call it Pemdas for short. Whether you want to say purple elephants marching down the street or please excuse my dear Aunt Sally, it's totally up to you. So, let's practice. So, P is first, parentheses. Let's look in this first problem here, 4 squared plus 25. Is there any parentheses there? No. You know what? I like to write down. Let's see what I'm going to use. I'll use this. I like to write my PEMDAS on my paper, because then I can cross out what I used and where I am, because sometimes I forget where I am. So we're looking at this problem, 4 squared plus 25. There are no parentheses. We don't have to worry about those at all. Exponents. Yeah, there's an exponent right there. And we really haven't talked about those much, but that means 4 squared is the same as saying 4 times 4. Okay, so 4 times 4 is 16. And now I have to bring the rest of my problem down. I like to write everything out. That's way I keep it straight in my head and in my eyes. Do we have, we're done. Do we have any multiplication? Nope. Do we have any division for D? Nope. We do have an A though, don't we? We have addition. We're going to go ahead and we're going to add 16 plus 25. So if you want to write it like this, 25 plus 16, remember you can add in any order. 5 plus 6 is 11. We put our 1 here and we carry our 1 over here. 2 and 1 is 3 and 1 is 4. So the answer to this question is 41. We just simplified it. Look, there's no equal signs up here. These are expressions. So they're called expressions because there's no equal sign. All right, let's look at this other example. I'm going to write Pemdas again. Parentheses, exponents, multiplication and division, addition, and subtraction. All right, well, let's look at this. We're looking right across here. Oh, there's some multiplication there. I don't see any parentheses. We don't have any exponents, but we do have multiplication right here. Here's some multiplication. 2 times 3. So that equals 6. I'm going to go ahead and I'm going to rewrite my problem because, you know, I have to because I gotta keep track. Now we have 8 minus 6 plus 7. Okay, we did our multiplication. We don't have any division. Do we have addition and subtraction? Well, we have both of them. But where do I go first? Well, I start over here at the left and go left to right and see what comes first. So my first is subtraction. 8 minus 6. Well, I know that 8 minus 6 is 2. I'm going to write that down. Then I'm going to write my 7. My 7 is just hanging out over here. I can't forget it. Okay, now, do we have addition? Now we have addition. So I'm going to add my 2 plus 7, and I'm going to get 9. So we just simplified this problem using our purple elephants marching down the street, or, please excuse my dear Aunt Sally, or Pemdas. However you want to think about it. Not too hard, is it? Let's try another one. Oh my gosh, look at this. 3 times 4 plus 8 divided by 2 squared minus the sum of 3 plus 2, parentheses. Oh goodness, there's a lot of stuff to do here, but you know what? Don't freak out, okay? Just don't do it. We're just going to do our Pemdas again. P-E-M. I love to write this on my paper so I can keep track of what I'm doing. Alright, well, let's look at this question. Parentheses, we're looking for those first. You see those parentheses? Oh yeah, right there they are. So we have to do that first. So our parentheses says 3 plus 2. And we're going to add those together. And that's going to give us 5. Okay, I can cross off my parentheses. I'm going to write my problem down again because I don't want to get messed up. 3 times 4 plus 8 divided by 2 squared minus 5. Okay, it's a little easier now. Let's look for exponents. Do you guys see any? Where do I see exponents? Oh, right there, 2 squared. Get rid of the exponents. 2 squared means 2 times 2. So what is 2 times 2? 2 times 2 is 4. So I'm coming down here. I'm putting my 4 there. So now I'm going to multiply. Or, well, actually, I'm going to rewrite my problem. Plus 8 divided by 4 minus 5. Okay, we're coming to multiplication and division. Now, if I go from left to right, we're going to go this way. Left to right, left to right. The first thing I come across is multiplication. So 3 times 4. I'm going to multiply that. 3 times 4 is 12. I'm just going to put my addition sign here. Do I have a division? I do. I have to divide 8 divided by 4. 8 divided by 4. I think that's 2. And then I'm just going to put my hanging out 5 here. Subtract 5. We're almost done. Alright. Addition and subtraction. Again, we're going to go in left to right. And we're going to do whatever comes first in our problem. So it is addition. So 12 plus 2 is 14. And I'm going to subtract 5. Alright, we've done our addition. So now we have to subtract 14 minus 5. I think I get 9. And there you have it. You have your PEMDAS. Well, okay, but what about fractions? Well, no different. Look at this. If we simplify, this is a fraction, this is in the numerator. We have 10 times 2 plus 4 times 5. So we have to do that first. Divided by 30 divided by 6. So we have to do what's in the numerator first. We have to simplify that. So we're going to multiply our 10 times 2 and our 4 times 5, and we get 20. That's shown over here. Okay? And then we put it all over our denominator, which is 30 divided by 6. So then we simplify the numerator. We add 20 and 20, which is 40. That's what you get here. And then we can simplify our 30 divided by 6. That is a 5. Okay, so then our numerator and denominator are 40 divided by 5, and that's just a division problem, and we get 8. So even though this looked like a hot mess up here, if you break it down into pieces, it works out perfectly. But what about fractions and decimals? What if you see something like this? 1/2 with parentheses to the third power. Well, that's just saying I'm going to multiply my 1/2 3 times. By, itself 3 times. So if I rewrite this like this, 1/2 times 1/2 times 1/2. I just multiply across the numerators. 1 times 1 times 1. That's going to equal 1. And 2 times 2 is 4. 4 times 2 is 8. So we just simplified this fraction. Not so bad, right? So far, so good? Whoops, sorry about that. So I want you to log into iExcel. In your teacher suggestion, you're going to see perform multiple operations with whole numbers. The quick code is UKB. So practice this for 10 minutes or when you complete 10 problems and then move on to something else. Okay? If you get a 70, a SMART score of 70 or more, you will earn 10 points. If you just try it and it's really confusing and you get something less than a 70 SMART score, you'll still get your 8 points. Alright, you can play this video again if you need to, but if you don't need to, just go ahead and work and then take a break. Have a great day.